So keep doing it. All right, I want to find the rational roots of this. Guide me through the process. Aspen.
Just factor it.
Factor. How do I factor this?
Okay, 4 times 2 is 8. It factors 8. They give you that at 8 and 1.
8 and 1. Love it.
And then you do the bracket things, and then 2x and x. And then it's 4 and 1.
Plus 1. With me so far? Good. Everybody here? Yeah. All right. Let's do going.
X equals negative 4 and x equals negative 1 half.
X equals negative 4 and x equals negative, negative 1 half. All right. Now, I've repeated this enough time. This is not a secret. We are going to start doing much bigger ones of these, right? And we're going to be stuck trying to factor things out, right? So because of that, it's important for us to try to limit the number of crazy possibilities. Because how many numbers are there, Aspen?
2.
No, how many numbers are there in the universe?
Oh, a lot.
A lot. Perhaps infinite number, right? And if there's an infinite number of numbers, there's an infinite number of things you should be able to guess. That's not good. Because that means you got to do these division problems an infinite number of times to get all the right answers. So is there a way to limit our guessing? And the answer is Descartes' rational root theorem. And that goes like this. He says, look, where did the 4 come from that we put here? Where did it come from? This 4 right here. It is the end one, right? If you think about it, that 4, we did 2 times 4 here and got the 8. And then we looked at this 8 and we said, all right, that 8 became part of this 4, right? So that 4 came directly, it's a descendant of that one right there, isn't it? And so this last number, could it have been a 7? Could we have had a 7 in here? No, because these two numbers multiplied together gave me this option, right? So there's no way a 7 could have worked even. So if I was guessing 7, I'd be wasting a lot of time, wouldn't I? Where did the 1/2 come from? We look back over here, right? The 2 came from where?
The first one.
This 2 right here. And so that 2 right there on the front ended up on the bottom. And this 4 on the back ended up on top. So far with me?
Yes.
And that's what it's always going to be, right? Because if there's a number in front of the very first thing, it's always going to appear in front of one of these x's, right? And if it always appears in one of these x's, it's always going to be divided to my answer. So here's what Descartes would say. He would say factors of, in this case, 4 divided by factors of, in this case, 2 are the only possible rational roots. So in other words, if it factors, these are the ones you can find. Has to be those. There's the only option it can be. Right? There's no way it can make a 7 because there's no 7s in here. Right?
Make a 4.
It could make a 4. It could make a 2. It could make a 1. So if I was looking for a list of possible factors for this problem that we just did, I would say plus or minus 4, plus or minus 2, plus or minus 1. Why? Those are the factors of 4. That's all the different numbers I can put back here, right? These two numbers have to multiply and make that number, right? So it has to be a factor of that if it's going to work. So factors of 4, 2, and 1 divided by factors of 2, which is plus or minus 2 and plus or minus 1. There's a complete list of rational answers. That's it. If you check these and none of them works, guess what? There's no rational roots. You got a square root situation. You get come with a whole nother tool. Does that make sense?
Yep.
Okay, so this gives us a list of things to check. Okay, it shortens our list of things to check. Sometimes you gotta go, it didn't shorten it by much, but sometimes it shortens it quite a bit. That make sense? Sort of? All right, then let's try. I'm going to try the first one that we could not do before we walked in the door. I'm going to do it as an example problem. I got x to the third minus 5x to the second minus 17x minus 6 equals 0. Now, first of all, ask me, can I keep borrowing you?
Sure.
Okay. Why can't I just factor this?
Because there's a bunch of things going on.
Bunch of things going on. Explain a bunch of things going on.
There's a cube root.
There's cube power, right? Cube power. There's a cube power. I don't have a factor pattern for that, do you?
No.
So that means we're in deep trouble right from the beginning. So we know we can't factor this. But we could create a list of possible roots, possible answers. Could we not?
Yeah.
Okay. What would be on that list?
Factors of 6 and factors of 1.
Factors of 6 divided by factors of 1. So, i.e., plus or minus 6. Plus or minus, what's another factor of 6? 3. Plus or minus 2. And plus or minus 1 all over. Plus or minus 1, which is kind of silly because that just divides by 1. So my list is I have to check 6, 3, 2, and 1. That's it. That's my maximum number of answers. All right.
So you have to do synthetic division for all of those?
Or we have to do synthetic division until we get 1. Why 1? Because once we divide it out, we have a quadratic. Do you know how to deal with a quadratic?
Yeah.
Yeah. We'll just go right to the answer after that, right? Does that make sense?
Yes.
So approaching this problem, I've got to guess which one of these is going to work. I've only got 12 choices. No, 8 choices. Want to pick one?
Sure.
Now, which one are you going to pick?
-3.
There's no wrong answer. -3?
Yeah.
Okay. We're going to do -3 just because you said -3. But as we get ready to do -3, did you cheat and look? Is it -3? No, it's not. Okay, good. So we're going to try -3. But I want to point out something else as I get ready to do this. You ready? I would choose 1 first. Why do I choose 1 first? Because 1's easy. Right?
Let's do 1.
Choose 1 first. But that's okay. Let's do -3 because that's fun. So -3. And here we go. Synthetic division. Are we ready? 1, -5, -17, -6. So far, so good? Doing some synthetic division. Here we go. Bring it down. I got -3. This goes up, makes 9, right? Makes 9, right?
Yeah.
So now I try 4.
Oh, sorry.
That's fine.
I'm trying to write this.
No, that's fine. Write it down.
-12.
-12. Please, please, please. Write it down as much. That's great. You're doing good things. I'm waiting because you're doing good things, not because you're spacing out and taking a vacation. There's no tense on there. Well, we got -29. Am I doing this right? Okay, looks like it's right. -29 times -3.
87.
87. So this becomes 81. Is that the right answer?
No.
No. How do I know that?
It's not one of 81. It's not one of the. No, actually.
It needs to be a 0 here. If it's a factor, it's going to give me a 0 there, right?
Yes.
That's our goal. Do I see a 0 here?
No.
No. That's not it. I need another one. Now, does that feel close or far away?
Far away.
Far away. So I might skip ahead to like -1. Is that fair?
Yeah.
Let's go -1.
Okay. I have a question.
Yes.
How did you find the 6, 3, 2, and 1? I still don't get that.
Factors of this divided by factors of this. So the only possibilities, right?
So 6 divided by 1.
So 6 or 3 or 2 or 1. These are all the factors, right?
Of what?
Of 6. Give me two things that make 6.
200 divided by 43.
3 times 2 is 6. 1 times 6 is...
Okay, but what about 6 times 3?
That doesn't give me 6.
I know!
Factors of 6.
6 times...
It's only factors of 6. Doesn't really matter. Yes.
In the synthetic division,
Yes.
don't you drop the first number?
Ah! You guys! I said I wasn't doing it right. God.
Nice.
All right, we gotta go fast now. 1, -3, -8, 24, 7, -21, -27. Is that better?
Is there one without an X?
All right. Woo! That feels much closer now that we messed that up. Oh well. We're starting -1. Let's do -1. -1. So I go down here. I bring down the 1. I get -1. I get -6. Agreed? Double check me, Chris. -6 gives me 6. Gives me -11. Which gives me 11, which gives me 5.
It's just really easy.
I'm just demonstrating it. A lot of people writing it down just for practice problems. They have it available to them. Now, I'm going to give you a little bonus right now. The remainders went from -27 to +5. I'm looking for 0. Is 0 between -27 and +5? Then there's a high likelihood that between these two, there's a number that's going to give me the 0. Make sense?
Yes.
And what number is that? -2. 1, -5, -17, -6.
Can we have our calculator for this when this song test?
Probably.
Okay.
Depends how I see you guys using your calculators. Bring the 1 down. That comes -2. Gives me -7. Gives me 14. Gives me -3. Gives me 6. Gives me 0.
What do we do if there isn't an answer?
Then you're out of luck, and we come up with some new tools, which we'll have in a moment.
Oh God.
Okay, so what have we done thus far? We've discovered that this is in fact a factor, right?
Yeah.
So if I'm factoring this down, which is our goal, this is now equal to what? X plus 2, remember we chose the opposite here, times what's left over?
X squared.
X squared
Minus 7x.
minus 7x minus 3.
Where's that x?
Is there any equation like the quadratic formula?
Where's that x supposed to come?
Because we chose -2. Yeah.
Is there an equation like a quadratic formula that just gives it to you?
Yeah, the rest of this called the quadratic equation. Right here.
Quadratic correlation?
Quadratic equation?
No, but what
Right here?
is there one that like goes from that one?
No.
Are you sure?
Not one you could use.
We could do it.
No. All right, so you got this? So far so good? And then from here, what can I do? Either quadratic equation or factoring to get my last 2. Does that make sense?
Yeah.
One of my solutions is going to be -2 when I'm all the way done. The other is going to be the ones I get from this. Good? Okay. So we'll take it from there.